what is the role of Cisco Nexus 1000V? A lot of things what 1000V is also done by 5000. Then why we have another series 1000V? The difference is that is hardware solution, this is software solution. We can say this is a bit cheaper than the other one, the 5000. So we are getting into software solution. We are trying to have a virtual access layer instead of having physical access layer. Instead of we connecting to 5000, we are trying to bring those features that is needed, that is provided by 5000 in 1000 level, in a virtual level itself, in an virtual access layer, instead of having a physical access layer. That's the aim of having 1000V. So most of the people don't even teach 1000V. If you try searching for 1000V in YouTube or any other source, you won't get that detailed information as we are going to see in our class. You will be having some videos talking on installation of 1000V, installation of VMware vCenter, and having VES, Virtual Ethernet module and Virtual Supervisor module. Only that much they touch. They don't really go deep into it, as we are going to go deep. So this is very important, though it is not much spoken in the real world as for now, but definitely it will be spoken much in the coming days. People think that 5000 has overtaken 1000V, which is not really true. Those people who really don't understand what all 1000V can do, the benefits of 1000V, may speak like that, but the truth is 1000V also has its own importance. This is also very important, even for exam. Even in exam we have 1000V. So we are not only studying for exam, we are also studying for using this in a real world scenario. So this chapter is going to cover 1000V, the entire module. Let's break into small pieces. Introduction to Cisco Nexus 1000V. Now it's a virtual server environment. Just a minute. Yeah. So in this chapter we are going to understand how the data center access layer network looks like before virtualization and after virtualization. So current virtualization environment we will discuss, and also we will see the Cisco solution for virtual switching, which is 1000V. Now we have seen this slide before when we were in CCNA level, end of rack and top of rack, and we are very much comfortable with this. Top of rack is nothing but having all the servers. It may be a rack mount server, or it may be a blade server or a C-series server. It's connected to 2000 series of fabric extender, and then the fabric extender is connected to the end of rack. So we got top of rack, and top of rack is connected to end of rack. What is the advantage? When you have a top of rack approach, we are not running cables between racks. We run less number of cables. That's one advantage. Less cost in spending on cables, plus it's more hygienic to look. But the problem is when we go for top of rack, the maintenance is a bit difficult. Even it is costly. Why? We have to spend 2 more additional device like 2000 series boxes we need to buy for redundancy. For failover, we may need to keep 2000 series fabric extender on each rack. So in that way it looks like a little bit costly, but the advantages are too huge when we have top of rack. The reason is it's more neat and hygienic to look, and easy maintenance and administration. And end of rack is like, we connect all the top of racks together like this. Minimum number of wires are connected to this 5000 or this 7000, and plus we have less number of devices on the end of rack layer. By having less number of end of rack devices, we save money, plus less cooling needed, plus less power needed. So that is very good advantage when we have end of rack. And when we mix top of rack and end of rack, things are really going good. That's why we have this type of approach in our data center access layer. So this talks about top of rack, as we already discussed, low cost cable, lower the cable cost, and fewer cable runs between the racks. And top of rack servers are connected to the top of rack device, which is fabric extender or fabric interconnect FI, which we'll be dealing with FI later. When we talk about UCS, we'll talk about FI devices, which is not in our area of study as for now. So end of rack is like this. We have less power needed because we have less number of devices, less cooling needed. So lower capital expenditure, lower operational expenditure. So these are the advantages of having end of rack. And if this is a 5500,000 Nexus, 5500 series Nexus, then that is going to be the control plane and the management plane for the server racks, for the top of racks that is connected to the end of rack, where on this end of rack we do all security kind of measures are taken, quality of service, multicasting related stuff. All those things are carried out on end of rack. When we have top of rack, we don't do anything on top of rack, much configuration. We do all configuration on end of rack. We have discussed these things in our CCNA level as well, which we called as fabric extender. Now, here, before virtualization, still we have not spoken anything about virtualization. We started with the access layer design in data center, top of rack, end of rack, the physical box, physical servers, physical cabling, and then now we are coming into the normal way of connecting servers to the switches. We connect one port to one server. That's the traditional way of connecting servers to the layer 2 box. It's a layer 2 physical box, and each port is connected to a dedicated each server is connected to a dedicated physical NIC cards on the switch. So any policy based configuration, any profile or any port profile I want to do, I do everything on the physical port. I go under the interface and I do all quality of service related configuration. If I want to put the server in one VLAN, I go to the physical interface that is connecting to the server. I go to this interface, physical interface, and I connect and I configure the VLAN. So this is the approach on a physical switch, that which we all know. When you type show interface Ethernet 1/25, you can see the MAC address of the internet interface, the physical MAC address, the status, and the number of packets received, the multicast packet sent, and all the stuff we can see per physical interface base. So if you find that one of your server is malfunctioning, if one of the server is malfunctioning, all that you do is you just go to that physical interface. You go to the physical interface and shut down to isolate the problem. So it was very easy because we had each server connecting to a separate physical dedicated port. So there was end-to-end connection between server and the switch port. It was easy to troubleshoot. And this is the overall appearance of the standard data center. We had one physical box with one application, like email server, Active Directory. We had a dedicated box. The reason why we had dedicated box, it's easy to manage, maintain, but the problem is very costly. Not only costly, it is also not fully utilized. So the amount of utilization, the resource utilization is very low, very less when we have a separate dedicated physical servers to each application that we want in our data center environment. That's why That's why we get into virtualization, where we run many virtual machines, many servers on one physical box. So multiple operating systems we have, and each operating system has its own application running, and this is what we call it as virtualization. Now when we have this type of approach, we have some challenges. What is the challenge? This is the challenge. This is the challenge. What it is, the entire virtual network that we have created is hidden behind the physical server. To explain this better, let me draw some physical servers, host on which we have VMs, and we got NIC cards, physical NIC card on the server, and this physical NIC cards are connected to a physical switch, layer 2 switch. So administrator has got visibility only to this level. Behind this, no visibility for the administrator, for the network administrator to be more precise. Only a system admin can see this VM machine, or the VMware engineers, VMware admins. Only they can see this each VM machine, and only they can assign some VLANs here. But for the network engineer, he has no visibility till this VM level. He can see only up to this NIC card level, physical level. So if you want to assign some sort of policy-based packet forwarding, or policy-based treatment for a particular traffic coming from particular VM machine, it was not possible. It is not possible when we don't have things like 1000V. There is no visibility if you don't have, let me come directly to the point, if you don't have 1000V, network administrators, they do not have visibility to this area. It's totally hidden. The physical, the virtual networks are created behind the physical server. This virtual machine is outside to the typical network control. So we got two layers now. One is virtual access layer and physical access layer. The administrator has got control only up to that physical access layer. Behind that, no control. So no special treatment for a traffic coming from one particular server from a VM machine is not possible. That's the challenge when we go for virtualization. Now here again, this explains what, this server has got 4 VMs, 4 virtual servers. This physical host has got 4 virtual machine, and this host is connected to one of the port, let's say fast Ethernet 0/12. Whatever you configure on fast Ethernet 0/12, that is what inherited for all these 4 virtual machines. There is no separate treatment for each servers in the virtual machine. There is common treatment. If you want to treat one traffic coming from one particular server, this is not really possible because there is no visibility to VM level. So multiple VMs running on a server connects through the same physical port. Physical port configuration affects all the attached VM instead of single server. This is the challenge. And port configurations are static and not transportable with the VMs. This is something new which you cannot really comprehend what it is actually. When I disconnect this cable and connect to another port, I lose all the profile, all the policies that I created for these servers. I created on this physical port. So when you move from one physical port to another physical port, you need to again recreate all those policy parameters. We need to reconfigure on the new interface. It is not transportable. It's not transportable. So port configuration is static and not transportable with the VM. So if I move this VM to this server, I just remove. VMs are only files here. It's a file. When I move this VM machine file, when I copy to this server, I'm not going to have the same policy that I was having when I was in this server box. Because the policy configured over here is different, the policy configured over this interface is different. Whatever is configured here is being inherited by this box. So it's not transportable. This is another challenge that we face when we have virtualization, VMware connecting to the physical switch. So when troubleshooting the network issues, the network administrator team has no visibility into the virtual server level. So if something is going wrong with this box, virtual box, there is no visibility. Only one thing this network admin can do is he can shut down this. If we shut down this, we even lose these services because I shut down here. Because there is no visibility till the VM level, I cannot shut down only this VM virtual NIC card. As a network admin, I don't have the visibility there, so I cannot go and shut down there. I need to shut down here to stop some misbehavior that happens on this one particular VM machine. So internal V switches. So this is what called as V switch provided by the VM machine. This is a switch called V switch. In the VM machines, in the vCenter client, we can have this V switch. The internal V switch and underlying VMs are hidden from the physical network. So a compromised virtual server will be only traced as far as the physical port. Further diagnosis will need to occur, but we are not able to do that. So standard tools, the networking tools for troubleshooting, they don't really go deep into the VM level. They only go up to this physical level from the physical network. So the tools are also not enough for us to troubleshoot VM level. We cannot go vSwitch level and see vNICs and troubleshoot. There is no option available for the tools. So if you compare network visibility only up to the physical network, only I can see individual server. Virtual networks, I cannot see, only I can see the physical server. I cannot see the individual VMs. Port configuration, I can configure only for the entire server, the entire host, that physical server, not to the VM. Network configuration is done for the physical box, the host, on the physical port of the switch by the network admin. And the VM admin and network admin join together to do some sort of VLAN configuration and so on for VM machines. So separate. There is no direct visibility for network admin to go deep into that VM level. So both VM admin as well as network admin partakes in fixing so few issues. Security policies only up to the physical server level. It's not going to see the VMs, it's going to see as one server. So virtual server environment requires a new set of network policies, and configuration practices may involve in a loss of security granularity at the server level. The reason is because we cannot go deep into the VM server level. We cannot really provide a complete satisfactory granular security configuration. We can give only overall security configuration for the entire physical host, not to the separate VMs. Now Cisco Nexus 1000V does this. It provides policy-based virtual machine connectivity. It provides mobility of network and security policies. It provides non-disruptive operational module. What it is, we'll discuss one by one. Now these three things are given by 5000 series as well, but that is hardware based. All the configurations are done on 5000, and you can see here with the help of 5000 I can see this VM. I can see this VM. I can have a special tag to talk to these VMs, and ESXi is there in the middle. Whereas 1000V is sitting right inside as a part of ESXi, as a software installed inside this ESXi, which is more granular and which is going really deep into that, very near to that VM missions. So 1000V, the software based, it becomes a part of ESXi because this is also software. We can see that 1000V inside ESXi, this blue border. Whereas if you see here, ESXi is separate and we have the initiator that is created with the help of 5000 is separate. So whatever the 5000 can provide, that visibility can also be given by 1000V like this instead of like this. Now we got 1000V installed in this. Let's see one by one what policy based VM connectivity means. So here this explains policy based VM connectivity. Through Cisco 1000V, what we achieve is policy based VM connectivity, meaning you can have a separate policy for web application, for the HR related server VM machine, a database, VM3, and then the other compliance on VM4. Likewise, we can have many VMs on many physical server. See how many servers you find. You have two servers here, two physical box, but how many switches you got? One virtual switch. This is like me having a layer 2 switch, having all the physical servers, 8 servers connected like this. So this type of feeling is what you get as an output. This switch, the orange switch, it's a distributed switch. So after configuring 1000V, what sort of feeling we get is, we get that we have only one base machine and all VMs on it. Actually it is two base machine. It gives you a feeling like you have a pool of hardware resource. This is one server, this is another server, so it's a pool, it's a collection. That hardware collection, hardware resource is being utilized by many VMs. So easy management. To be more precise, a centralized management we get when we have 1000V. We need not to manage one server separately and another server separately. So that is one advantage. I think I'm going away from the topic. The topic here is policy-based VM connectivity. What it is, each VMs need different policies because they belong to different departments. One for web, one for HR, one database is for, one virtual machine server is for database, one for compliance. So they need different treatment, different policies. Now because I have 1000V, I can see up to this level. I have visibility up to this level. I can go to this level and put the policy that is needed for the traffic that comes out from this VM. So we got policy based VM connectivity, and this policy based connectivity is defined in the network itself, this virtual network, using the virtual vCenter client software to be more precise. And to identify the VM device, we have UUIDs like a MAC address, which will be tagged and sent to and fro. We'll talk about these things later as we go deep into 1000V. So what we have is, we have policy based VM connectivity. Now mobility of network. This is really wonderful. This we don't even have in our physical network. This is the point that I was trying to say here. Like port configuration is static in the physical switch and not transportable. You remember I told you, when I move this VM to the another host, physical host, whatever this VM was experiencing when it was in this server will not be the same thing that it will experience when it moves to the other server, because on the physical port whatever is configured is what going to impact. This physical port configuration and this physical port configuration may be different, the policies. So when you move VMs, you lose all the policies that you had when you were here, whereas in VMs this policy is transportable. That is what we call it as vMotion. You see here the previous diagram was having VM1, VM2, VM3, VM4 on server 1, the first server. VM5, 6, 7, 8 was in second server. Now for some reason all the VMs were moved to the second server. Maybe the first server might have gone down. Physical box might have gone down. Now all VMs started using this hardware. Now it is having, actually as I told you, because of 1000V you get pool of hardware. According to the VMs, they don't see this as a server, separate server, and this as a separate server when we have 1000V. Both the servers are considered as one base pool of hardware. So when one physical hardware goes down, no worries. We got the backup, we got the failover. So all these VMs are moved to the other server and without losing any security properties, any policies. How? It is how. This is how, because of we not binding the policy to the physical port but to the VM itself. Rishi, you have any question? Okay, Aparna. Yes, it will definitely, because previously we were having more processor, more RAM and so on. Now when you move, yeah, definitely there will, but we still have the service. It's not going down. We are not comes back. Correct. So we are not losing the service. Right. So we got high availability, we can say HA. This word is very often used word in our Nexus. High availability, HA, high availability. So sometime I may be using the word HA as we go deep into our Nexus studies. So we got high availability because of Nexus 1000V. Now one beauty here is we are not really focusing on the high availability in this place. In this place what we are seeing is when you do a transfer of VMs from one server to another server for some reason, we are not going to lose any security policies that was there when the server is here. When the server was here, you may had some security policies when it was connected to this virtual ports. When I move to another box, am I going to lose those security policies? No. No policies are going to be lost because I move from one physical box to the other physical box. How? Correct. The security policies are binded to the VM machine itself, VM servers itself, not to the physical. Anyway, there is no physical port. We have just VM. We have only vNix. We are not going to do any policy for binding to vNix. Rather, we bind it to VMs itself. So as the VM moves, the policy is also carried. That is what we call it as vMotion. vMotion. This vMotion is a common term for both Nexus 1000V as well as for VMware. So we got vMotion for network, ensures there is VM security still maintained as we move the VMs from one physical hardware to the other physical hardware. The reason is all the physical hardwares are seen as one hardware pool. So we got mobility. Next is non-disruptive operational mode. Let's see what it is. Non-disruptive operational mode. Now because we have 1000V, we have something like, this is one reason again, this also brings that same point, ensures the policy persistence as we move from one hardware to another hardware. But to be more precise with this topic, the answer that I can give for this non-disruptive operational mode in here is the management and the control. So one is you got a unified network management. You are not going to manage this server separate and this server separate. To put this in more precise manner, I'm not going to configure separately this switch and this VMs. I'm going to have all these servers seen as one virtual switch, and I only deal with this switch. I don't deal with this VM separate and this VM. So you got unified network management and operation, improves operational security. How, as you already know, we are going to configure all the policy based thing on VMs as it moves. We got an improved, so it is not disruptive. We got improved operational security, enhanced VM network features, meaning we got high availability, and the policy is persistence. It's not going to change as it moves from one machine to another. And we got VM level visibility on the network side. On the server side also we got VM level visibility. Reduced operational workload, meaning for the servers to maintain, if there is no 1000V, there is too much of workload for the VM admin and for the system admins. They don't understand much about networking, so they were having too much of hard time configuring, interacting with network engineers, trying to understand what they say and doing something else than what the network engineer expert. It was a big burden. Now there is a reduced operational workload for the server engineers, for the VMware engineers. So deployment time is also very easy. You know how it is very easy. All the configurations are done by the network admin in the VMware client. Network admin does everything on we call it as VSM, Virtual Supervisor module, in a CLI mode in our Nexus iOS. We do all the configuration and we make all the policy based configuration available in a graphical user interface in the vCenter for the network admin to simply, for the server admin to simply use the drop down menu and bind the policies that we created here to the VMs. So deployment time is very less. All necessary policies we configure in CLI, and that is made available for the VM admins, just in a click he gets it. He will see in a drop down menu, and he maps the policy to the VMs that he is trying to add, and the deployment is very easy here now. So even the scalability is yes. Very good question. Now here we have a centralized body vCenter. We will configure on it, and then we will group all the other servers. It is centralized management. It is not going to be managed separately. You will get a very clear picture. Yes. Yeah, tell me. Yes, this 1000V. Now this confusion comes because we have not seen the deployment. Rishi, can you repeat? It is dragging. Hello. Yeah, Pep, I can hear you. Yeah, I'm hearing you. Supervisor module. Okay. See this. Yes. See, this has got two different modules in Nexus 1000V. One is VSM, supervisor module, and VEM. Now we don't install VSM on every machine. We will have in one of the server, or as a one of VM you can have this VSM, or you can have in a separate box, or you can even have a physical 1000V, that is 1100 physical. It's not a VM, it is not anymore V anyway. The supervisor module can be a physical box, or it can be a VM on one of the server, and that can manage all other servers in a cluster. Yeah, I know, definitely. Definitely you will be getting a very clear picture, but not this early. This chapter is overall, and then following chapter is again going to give you very good hard deep understanding about what is there before 1000V. Only then you can really understand all these things, because there is something called vSwitch, there is something called VDS, virtual distribution switch. We need to first of all understand these things. Now this chapter is only a overall 1000V delivery. So you're not really going to get deep into everything today itself, but these things will be dealt properly as we go into different classes on 1000V. Maybe on the third day you will get a very good answer. On the second day also you won't get the clear answer for this. The third day you will get the answer for this. Now but to an extent, as far as you can understand, now I have explained what is that. You can have the VSM, a supervisor module, which is for control plane and management plane, on a VM machine. This control plane is the one which puts all this in this form, in a group manner, in a virtual switch. And this we called as VEM. Now these VEMs, for each device that we get, these VEMs are grouped as one virtual switch by VSM. That's why we called as control plane, control and management plane. And this control and management plane job is only to control and manage. This is not responsible for any traffic flow. So it can be a part of VM, or it can be away from the servers. It can be a separate box connected to this network, and from here this can control this ESXi or ESX server. Right. So this is again the three things achieved: policy based VM connectivity, mobility of network and security properties, non-disruptive operational module. Now, Nexus 1000V also provides you security and policy enforcement. What? Security? Why? Yes, security is needed for me for all the traffic that is coming out from here. I don't want some traffic to go to a particular portion of network. I need some ACL. I need some, even if some traffic is coming from outside, I need to see whether this is a malicious traffic or acceptable traffic. So I need some sort of firewall on this. Yes, you can have a firewall. What firewall I can have? This is a virtual switch. I can have ASA on it. What? ASA? How? Yes, there is an ASA called VASA or ASA 1000V. I install that software firewall in this and I can have security. So security policies and policy enforcement is one of the features of Nexus 1000V. Operational management, organizational structure. Let's see one by one what it is. Security and policy enforcement. Now, you can write an ACL. That's one security feature. VM level security. And then we can also have authentication, authorization, and accounting by using TechX and Radius server. See, whatever you do on a physical switch is also possible now on a virtual switch. I can have private VLAN. You remember private VLANs? Promiscuous mode, community, isolate. That type of securities also we can give now here on a virtual environment. Next point is the operation and management. Now we can have multiple ESXi with single management point, meaning with one VMware vCenter client software I can control multiple ESXi. From a single machine I can control multiple physical host which has a lot of VMs in it. Multiple physical host with multiple VM on it, I can configure from one point. How many? You will get answer on the third day. How many ESXi I can control from one single point? It's really very big. Now, network-wide management integration. So we got visual, we got visibility till the VM level. We have an integrated network-wide management, automated policy migration. As you move the VMs, the policies are migrated, and the configuration consistency. How? Because you got single point. With that single point VSM supervisor module, you control the entire VM world. So you got a consistency all over the virtual access layer. And this is also possible in service software upgrade, because there is high availability. If I want to do some upgradation on one of the hardware, I can still do it without disturbing the traffic. I can simply move all the VMs to the other machines and upgrade this machine, and then again move back all this to this one and upgrade the other one. So in service software upgrade is also possible. Network monitoring and accounting is also easy. We also have VMware monitoring window where we can monitor. We also have some additional third-party windows to monitor all the VMware. This is one of the example. DCNM is a monitoring tool which helps to monitor all the VM uh, devices, VM networks, and so on. So the next feature is organizational structure, meaning, as I already told you, we can easily monitor the entire VMs by using Cisco CLI Nexus. You can use a lot of show commands and do the management stuff. You can also manage them with the help of Cisco's DCNM. Just a minute, I'll get the abbreviation of DCNM. I just forgot it. I'm not getting it immediately. I have written here. Excellent. It's a tool provided by Cisco, Data Center Network Management. And this is another tool for the management. So organizational structure is also fulfilled here. You can see everything in DCNM. I have seen someone showing how to use DCNM in YouTube. It is really awesome. I have not used DCNM, but I have seen some videos on DCNM. It's in a single click you can see any portion of VM network. Very nice. This is again Cisco's DCNM. It's a Cisco's tool to monitor, which works along with the 1000V as well. Not only in VMworld, it also works with the physical network world. It used to monitor. So the next is the role of admin before Nexus 1000V. The role of VM admin is really huge. He has to do everything, and network admin has nothing to do in the VM world. So vSwitch configuration, the VM admin has to do for every ESXi host. See this, there's a huge difference. Every physical host has to be configured separately, individually. There is no group configuration. And port group configuration for the entire host, not for each VMs. No. This is different actually. For VMs you can have, but it is local to VM only. It will not be visible to the outside, and it has to be done for each ESXi host. I cannot have multiple ESXi in one cluster and manage all together. I need to manage separately. So per ESXi host. Network admin has nothing to do with this too. And adding an ESXi host, yes, it is using vCenter. Even now it is using vCenter. And then NIC teaming. What is NIC teaming? Like an ether channel. In VMworld we call NIC teaming. NIC teaming is nothing but binding NIC cards together. That's what we do in ether channel with LACP or PAGP. Here NIC teaming is per switch, per vSwitch. NIC teaming is done per vSwitch, grouping of ports, virtual ports. I'm sorry, grouping of physical ports per vSwitch. You got a vSwitch, virtual switch, and you got VMs, and you got hypervisor, and you may have 1 or 2 or 3 physical NIC cards, NIC cards. You do NIC teaming for high availability. Even load balancing can be done, but not now after 1000V. Right, so NIC teaming configuration is per vSwitch. VM creation, it's purely vCenter based. Security, no security. Visibility, only vCenter level. Management, only by vCenter. Only vCenter can see all the VMs. Outside networks cannot see. So there is no role for network admin to do in standard VM environment. Now with 1000V, the load is balanced. vSwitch configuration is done by network team, same like you do on physical network. We do it on CLI mode by the network admin. It's a switch configuration. So why we pressurize the VM admin? He doesn't know anything much about, he don't know much about networking as we know. So it's automated now. For him, no role. Whatever you do, accordingly this will start working. vSwitch will start working. Policy based, we do it. No burden for the VMware admin. Adding an ESXi host, anyway it has to be done by the vCenter. We cannot add it from Nexus 1000V, we cannot add it. This Nexus itself is a software. V works along with Nexus VDS, Virtual Distribution Switch. We'll talk about VDS later, it's coming. So it is created only on vCenter. Adding a host, adding an ESXi host, adding a physical box to the cluster. NIC teaming configuration, we do port channeling. And here it is teaming happens automatically as you do port channeling on the physical box. Automatically the NIC cards will be teamed, grouped. VM creation done on the vCenter, not by the admin, network admin. Security, yes, we do provide security. With the help of 1000V, we can write an ACL, private VLAN as we already see. Port security also, if you need really, you can do it. Sometimes it may create some problem, so you need to be very cautious when you enable port security. Why? When we enable port security, by default the maximum number of MAC address allowed is 1. You may think that I have only one VM machine, only one MAC address. No. VM machine has one MAC address and the ESXi server has got another one. ESXi has got another one. So it may put into error disability state. If you know port security, you know what it is. You may think, I'm setting maximum MAC address allowed 10. And you may say, I have 10 VMs, so I'm allowing 10 MAC address. Actually, there is another MAC address for this ESXi. So this 10 plus 1 is 11. What it will do, if port security is configured with 10, when the 11th MAC address comes, it will shut down by default. So none of the VMs can communicate. So port security, you need to do with cautious. TrustSec and all these things can be done by the network admin. And based on the policy, this VMware admin is going to choose. This will vary. Visibility till VM level, both have. Management, as we already discussed, you can use CLI or XML, application programmable, I think it is interconnect something, and then SNMP or data center network manager. So this chapter has given an overall view of virtual switch, a software solution that Cisco has provided. The next chapter is going to bring us a detailed information about what is there if there is no 1000V. If you don't have 1000V, what all there provided by VM. So let's get into it. Again, few things may be repeating again, but there are a lot of things to be learned from this chapter. It may look like somewhat repeating, but it's not going to be really boring. There are a lot of things to be learned even here. So standard application architecture, as we already discussed, there is a separate application running on separate OS on a separate hardware. This is standard. The problem here is there is advantage as well as disadvantage. Advantage is this: if one of the application is malfunctioning, I can just shut down the port. So if one of the hardware fails, I am not losing many services, I lose only one service. Or if one of the application is malfunctioning, I can shut down that particular link that connects to the physical host. Drawback is we are not utilizing the hardware proper. So plus another drawback is more devices, more pressure on administration, and then the cost. You need to pay more power supply, you need to maintain more space to manage all this device, more cooling is needed, and so on. So this is basic virtualization server environment, where we have one big physical server with a pool of hardware, on top of it hypervisor, ESX or ESXi, and got VMs, and then the VM itself accessing those allocated resources from the pool. So here we got multiple applications running on single device. And one important thing is each VM has got independent MAC address provided by vMotion itself, virtual MAC address. But if you want to change it, you can change it. There is also an option not to change it. Even if someone tries to change, it won't allow. But if you want to change, you can change it. And you got separate operating system for each VMs, and separate dedicated shared hardware provided for individual VMs. Right. So these are the benefits, as we already discussed. There is less number of physical server, less number of power and cooling needed, and less number of cables running between the physical box, because we have less hardware, less cables. And we got centralized administration. Multiple VMs can be, multiple servers can be managed by one device. So easy server deployment, like what? If one server goes down, all that I need to do is I need to copy these files from the hard disk to the another machine. So deployment is very simple, very fast. I need not to put in some CDs and install the operating system and then the application and then copy down all the previous logs. No. Deployment is very easy. In few minutes can be deployed. The challenges is lack of administration separation, meaning you don't have visibility. See, it is coming like a repetition of the previous chapter, but slowly it will be adding something new here. Lack of administration separation, you don't have visibility to VM level, and shared architecture security concern means security, whatever you configure on this port, physical port on physical switch, is for all the machines though. So there is shared architectural security concern. There is no precise. Lack of VM level LAN and SAN management. You cannot manage SAN also separate. See, if you're hard, if just a bunch of disk JBOD is being given to these VMs, we don't have a visibility even to those disks that has been shared to these VMs. Plus lack of VM LAN. So even LAN as well as SAN is not managed comfortably. These are the challenges. Now, benefits of VMware virtualization, the additional benefit is you can cluster them, you can group them. Instead of you treating this as separate box and this as separate box, we can cluster all these boxes together, and we can have vMotions. We can move one VM from one to the another hardware box without losing any policy or security related policies. There is also high availability. As one physical host crashes, you got the other one in to support the failover. And distributed resource scheduling, DRS. So as already you raised a question, like if one of the hardware goes down, won't there be too much of load here? Yes, but still you survive. That's what cross cluster resource pooling. We got all this resource in one pool, and where one part of a pool goes down, still you got the other supply, resource supply from the other part of the pool, which we call as distributed resource scheduling. So what is that? One by one we are seeing how it is highly available. As we see here, this crashes and all the VMs are moved to this one box. High availability. Now the time taken for this vMotion is just a cool boot, meaning if you start a VM machine, how long it takes to boot? Very less time. When you boot a laptop or a computer, physical box, it takes much time than you boot a VM machine. Cool boot, VM machine. It's not a hard boot. Cold boot. So less time, in less time, it can be moved here and booted here in this hardware, and it's more available. High availability. So next is a distributed resource scheduling. See this one here, hardware is not. Yes. No. Can you repeat again? So this one has got what? 4 GB. No. Previously, these applications were running here. Now when this crashes, still these applications are running in very less downtime. It can come back again because it starts running on here. So you are not seeing denial of service. You are not denied from the service. Service is still running, maybe a bit slower because it is running on one single box now. Previously it was on the other box. That is what high availability. See, high availability in this place, this is the meaning. We are going to see high availability coming again and again. When I talk about Nexus 1000V on the third day, I'll say we'll have 2 VSMs, Virtual Supervisor module. That is again another high availability. So high availability is wherever you have some redundant, then we call it as high availability. Now here, distributed resource scheduler, DRS, what it is, see, this is very beautiful. Now here too much of process utilization when you compare to this one. Here it is only 45 CPU utilization and 50 memory usage, and here it is going more than 90. Now sometime it may get crashed after some time. So before it get crashed, when a user sets a threshold, that's very important. We need to set the threshold. When the threshold is exceeded, the DRS agent will either make the recommendation for it will tell the administrator to migrate, or it can automatically migrate one of the VM load to the other box so that this will go down. You can see that one pictorially in the next diagram. This we call it as distributed resource scheduler. Distributed resource scheduler. Using vMotion, the servers stay running throughout the process and the application remains unaware. So this application is simply moving to the other device hardware and start running without knowing that it is running on another physical machine. Previously it was running on this physical machine and seamlessly it is moving to this one. It is possible through DRS. Now these are all not because of 1000V, these are all already there in VM. Now we are seeing what is already there and what is not there also we will see, and what Nexus 1000V provides on top of all this also we will be seeing. That's why we are going deep into all VMware related stuff. Next, VM mobility. We already know that we can migrate VMs through vMotion or distributed resource scheduler, as we saw in the previous slide. So there is high availability and physical switch ports. They are attached to the chain. So you got all the hardwares connected to one physical machine. So if something is going on, if it is CPU utilization is going beyond the threshold, it moves from here to here. How? Not magically through wireless. Anyway, it has to go through this. It is moved. This will start running here with the help of this physical switch. Now this shows us that we got a virtual NIC cards, we call it as vNICs, and we got physical NIC cards, we call it as what? vMNICs. You may ask why you call it as vMNIC. It's a physical one. No, it is vMNIC. Right now it is dedicated to vMotions. It's vMNIC. But this one we call it as vNIC, which is there on the V switch. The software NIC cards on the V switch, we call it as vNIC, not vMNIC. The physical NIC card we call it as vMNIC. We got the hypervisor. On top of it we have a V switch provided by VMware itself, and we got all the VMs, and we got a catalyst switch. Now if I want to do NIC teaming, I no need to go for NIC teaming, which is a software solution provided by VMware. I can do what? As a network admin, Ether channel here. It is supported. So this is how virtual network looks like. I think it's a repetition. This is also again another repetition. What is that? The network admin has visibility only to this level. The physical access layer. The virtual access layer, no visibility. No visibility. Now not only on the LAN, even on SAN there is no visibility. Here we see that there is a lot of storage. We call it as JBOD. Just a bunch of disk, JBOD. And you see this green color given here. This pink color here. This red color here. This yellow color here. Here. So what happens is through VMware we can also share a portion of disk, and that portion of disk may have a lot of VMs in it for which we don't have visibility. We need visibility. That's why MDS, all the stuff comes. It is not spoken in detail. This is not related to 1000V here. So not much detail we see here. We will be seeing when we talk about MDS. Same thing, it's coming here. There is no visibility, so there cannot be a separate quality of service applied to each VMs because there is no storage visibility. Same like the story in a LAN environment. All right, now a few things you're going to understand here pictorially. It is very interesting and very important. VMware components, like we have what is that, vCenter server, which helps to manage multiple hosts. But this is not really a GUI, a CLI kind of thing. We need some Linux command to do all the stuff. We have again nice GUI tool, vSphere client, which really manages even the vCenter server. So you can see, most of the time we'll be working on vCenter client, which is a GUI tool which helps to add some VMs, which helps to put all the ESXis in a cluster like this. See, I see 2 virtual switches. So to have a centralized control over multiple hardwares inside which you got VMs, you got what? vCenter. So this is one component. Next is host. So the physical hardware, the physical server that has got VM host, VMware operating system, like ESXi or ESX on a bare metal. The VM operating system provides a functionality for creating a virtual servers known as VMs. We call that particular host that has got VMs on top of ESXi, the hypervisor, as VM host. These hosts can be managed utilizing the Linux-based command interface on CLI interface. That is, if you are using server, as we saw in the previous slide, vCenter server, then it will be CLI based Linux command, or vSphere client, which is a GUI. So vCenter server supports this. Even client also supports. It's coming in the next slide. So vCenter server provides a single point of management for multiple VM hosts, as well as the tools used for advanced VMware functionalities such as vMotion, high availability, like clustering, and distributed resource scheduler. vCenter server can run as a physical box, or vCenter server can also be one of the VMs in a vSwitch on a host. vCenter server is required for the feature. Okay, why we need vCenter server? vMotion, high availability, and DRS. Client. vCenter client is preferred for it's a preferred management tool because it's GUI for a VMware ESXi server, as well as a management tool for vCenter server. So to manage using GUI, we need what? vSphere client. So this is how the vCenter client interface looks like. You will have a topology panel. You will have a lot of VMs connected, the IP address and all the stuff here. It's not clear. This is very small, and there are a lot of tabs here. When you click on tabs, you can add some VMs to some VLANs. We can add some profiles. So a lot of options. You can allocate some storage to what of a VM machine, a lot of tabs here, and a lot of things can be done through these tabs. This is how it will look like. What happened? Right, the next is the summary. So this chapter has given something new information, like how the client participate in virtualization, what the role of server, and then we saw few introduction to storage visibility, and also the drawback, the visibility that is available if there is no 1000V, and we talked about NIC teaming here, and we discussed here how the mobility happens, because we got a physical box connected to all this machine. vMotion is possible, and distribute resource scheduler and high availability when the hardware goes down is possible. This is what called as vMotion, and distributed resource scheduler. And we also discussed about high availability, how it is and what it is. Clustering, the advantage of clustering is what the high availability, vMotion, and distributed scheduling. So the older scenario after VMware. As I told you, the first chapter was the overall introduction. That's why you saw some introduction to 1000V as well, which is not spoken here. So the next chapter will be again a continuation of this VMware only. It's not something going to talk about 1000V. Only after we finish this chapter, we will be getting into 1000V, which we'll see on Monday.